All right, welcome everyone to another edition of the Subseasonal Forecast Contest. Today is, check my date, October 28th, forecasting HDDs. And we have a special guest today, Dave D'Arcangelo from Susquehanna. We're going to turn it over to Dave here in just a second. And our agenda today is our pretty usual kind of flow. We're going to start with attribution and then go into the forecast and hand it over to Dave. But excuse me, before we do that, I did just want to cover a couple new items we added to the forecast contest UI. Zach may just talked about this in our weekly email, but I thought it would be helpful to take a minute and see if there's any questions. So based on feedback that we've got from a number of folks over the last year or two, we've added this functionality where you can basically create your own United States temperature map. And so you can see the new functionality here, or I'm sorry, the new options here. So basically, it's not exactly drawing in the picture, but you're able to select above normal or below normal HDDs, and in the summer we'll switch to CDDs, for each of these 5 regions. These 5 regions are the EIA regions, are commonly referred to in energy weather. And if you need a reference map, you can click here to see a reference map of the outline for those regions. So you've got your East region in blue, Midwest up in green, South Central in orange, down Texas, Mountain in the mountainous areas, and Pacific along the West Coast. So you can click on that if you need that reference map. Otherwise, it's a pretty straightforward process. And remember, we're doing this in HDD space. We're trying to kind of stick with our energy private sector themes here. So if you think everywhere was going to be above normal demand, like a colder than normal forecast or above normal HDDs, you click on the above. And let's say instead you thought there was going to be above normal HDDs everywhere except for the eastern states. In the eastern states, you thought it was going to be warmer than normal or below normal demand. So you'd click there. And then the rest of it, you fill in the rest of your forecast as you typically do, hit submit. And then after you hit submit, if you want to see your output, you can go over to the weekly forecast table. So I'll show you what I did from this past week. So this most recent forecast, and of course we just started this, so you can't go back, beyond this week. But you can go to the forecast that we submitted yesterday. Here's my name, Dave Margolin, my forecast information, and now we have this new column for the forecast map. It's optional, so some people, if they don't produce one, I think it will say not available or something like that. But if you do, I'll click on it. Your map should come up. I should probably add a legend at some point, or we should add a legend. But the idea here was I was forecasting below normal demand or below normal HDDs across much of the country, with the exception of the South Central region where I was forecasting normal, or kind of that gray color.
Hey, Dave.
Yeah.
What's the threshold for which above and below kick in?
Yeah, that's a good point. The truth, we don't have one yet. So we have to kind of nail that down. What we're kind of doing, and I should have said this beginning, this is kind of, we're experimenting with this, right? So we're not even verifying it at the moment. In the future, we do hope to add like a verification type metric for it. Right now, we're just kind of testing it. We want folks to look at it. So, you're just kind of, it's more so that we can all look from a high level view and say, hey, I think I was forecasting kind of above normal HDDs in the West, below normal HDDs in the East. Let me go to my Maxstar page and see what verified, right? The idea is just so that we have something that we can start to compare and look at and think of at a high level. But to Dave's point, at some point, especially before we actually have a way to verify it objectively, we are going to have to come up with some reasonable thresholds, and I'll probably solicit feedback from you guys in order to determine what that is. that was a good question. Any other questions? That's basically all I was going to share on this. All right. No? Okay, we can move on then. Um, let's see. So let's start with attribution. So let's look back. This week was our first week that we verified in HDD space. And just so everyone knows, we did add another column here. So you could look at season to date HDDs. And, there's only one forecast. There should only be one forecast. If anyone sees any bugs or anything like that, occasionally when we transition seasons, we run into something. But I think these numbers are legit. I think they're good. Again, there's only one forecast because this is the forecast from October 6th was the first forecast to verified. All right, well, getting into it though, I thought, and I'm actually going to turn this over to Dave in a second, or ask his opinion. I was looking at this earlier, and this verification I thought was interesting. We have a lot of these, I guess. The verification, the number was 49. And looking at the CRPS scores, our performance scores, a number of folks did quite well, including Dave D'Arcangelo, who's on the phone here. Again, we had what I said. The verification was 49. You can see at the bottom, or just over 49. In fact, I think there was a perfect score. Yeah, I think, or a perfect center line score. Zach had a perfect center line score here. I don't know if he's on the line. But did quite well in terms of center line forecast. Again, a number of folks did quite a bit better than the 30-year normal. Remember though, this performance metrics takes into account your spread, and so that's why Zach didn't get the highest CRPS. Folks who had a very low spread and were close in terms of their center line actually did a little bit better. So Paul Roundy had a very tight spread, I guess you could say like a high confidence forecast. Did quite well, and one of the teams there from Missouri also did quite well. But what I thought was, and what I want to point out here too was the ECMWF did quite poorly. Was one of the worst forecasts here at minus 21. What I thought was interesting, I'm going to pull up the verification, and so let me see if I have the links up right. Yeah. So this is let me switch back. This is that was the upper levels. Let's just switch and look at the lower levels here real quick. I didn't want average temperature. I wanted average temperature departure. And you could see, yeah. So you can see out west and in the northwest, north central, some really, really strong cold anomalies, right? We know that, that air mass is coming in right now. There's been a lot of early season snow and really some cold weather. I saw some reports of temperatures. One of the groups was reporting how it's pretty interesting that there was like 100-degree spread in across the United States. I think some places in southern Florida were in the 80s, like Key West, and some places in Colorado were like minus 10 or minus 15. But anyway, really cold in the northern states, really warm in the east. But then when we look at and this worked out to be about 49 HDDs. But then looking back at make sure I get the dates here right. That's not the right one. Yeah, here we go. Now looking at what the forecasts were showing, you've got the Maxar on the top left, and you've got the EC, which we noted did really poorly in terms of at least an HDD number. And then there's the CFS. And I thought this was really interesting, right? I mean, clearly from a pattern perspective, a temperature pattern perspective, this is one of those situations where, you're pretty wrong, right? There's no nice way to sugarcoat this. The areas that were forecast to have some of the deepest reds and above normal temperatures turned out to have some of the coldest anomalies. And I just want to I want to go back to one other thing here before we open it up. I want to go back to the map we were just looking at, the 500 millibar map, because sometimes we'll note that that you can do pretty well in terms of in some cases getting the hemispheric pattern right. It's just that regionally across the United States, maybe things just don't work out a little bit. This was a situation, at least in terms of that sort of the Pacific North American sector. This was not one of those situations. So note here where the ridge, this big anomalous ridge is across the Eastern Pacific, the most anomalous ridge across the hemisphere, right? Across the Gulf of Alaska up into Alaska, whatnot. And I already opened these images, but you can click on them from the website. Yeah, here's the EC 500 millbar pattern for that same period, approximately. Note the Gulf of Alaska and Alaska pattern, right? Now there's actually a weak trough here, and it's actually arguably the strongest trough, other than down near the Antarctic, on this map. And then what about the CFS? That's the EC. What about the CFS? No, same thing, same thing. So in fact, a little bit of a stronger trough. And I'll just switch over one more time, just so you can look at them kind of side by side. Again, there's the models, and then there's what happened. So I want to open it up now. And Dave, maybe I'll put you on the spot here. I know you look at these things more than anyone else. Do you have any thoughts in terms of this forecast, in terms of the verification here, and why the models maybe had the problems they had? What drove some of these errors, and are there some lessons learned from this forecast?
Yeah, sure. Thanks, Dave, and thanks for the invite today. I love this forecast. It's a fascinating verification and a lot of moving parts, and it's a really great insight into kind of the subseasonal space, or really even model space, in terms of how difficult it is. But the reason I love this is I love this time of year. October, November in particular are really great, great studies in the murky window we cross from the kind of fall to winter, when you have interesting and unique handoffs between what's happening at the tropics and things that are trying to happen at the mid and high latitudes. And so that murky forecast window leads to some verifications like we're seeing now. And if you go back to the verification for one moment, Dave, I think that the thing that, there's two things that stand out, right? One is the extreme cold in the plains and Rockies.
Oh, sorry, Dave. Did you want the temperature verification, or?
Yeah, just the
Okay.
CONUS lower 48.
Sure,
Yeah.
sure.
So the two things that stand out is obviously the cold and how extreme it was. And I think I saw on Monday, it was minus 31 near Fort Bridger, Wyoming, which if it holds up will be the earliest minus 30 ever recorded in the lower 48, which is pretty remarkable.
Jeez.
But the other thing that catches your eye on this one is, and I take little solace in this, right? Like my verification was decent, but it's almost like feeling like you got the right answer for the wrong reasons, or you got the right answer and didn't show your work. Because if you look at the zero line, which runs from central southern Michigan through Chicago to just north of Dallas, if you move that zero line 200 miles farther east or farther west, and you really start covering some significant demand centers, right? You cover Dallas, you get, the core of Midwest cities. To the warm and cold side, you could really blow this forecast out. You might have seen a number that was in the 60s, or might have seen a number that was like in the, mid to high 20s for verification. And I think therein lies the challenge with not just making a forecast, but kind of depicting the uncertainty, right? So that's a fairly vivid line. And it looks like now the forecast that we did yesterday, we may end up having something similar transpiring in 16 to 20 days from now. So we may repeat this kind of verification at a macro level. But if you go back to 500, the hemispheric view, Dave, this is maybe where we can talk about some of the challenges that were occurring. This is the verification over the window, but if you backed it up, say 5 or 10 days, what you witnessed, you can shift that period, Dave, maybe another 2 days prior. Perfect, right? That's great. You can leave it there, Dave. That's fine. A couple of things were happening, right? Hurricane Epsilon was kind of in the central Atlantic, south and east of Bermuda. And I think some of what we'd seen early to set this up was, the blocking that formed in the North Atlantic was maybe perhaps a secondary effect of Epsilon. We'd also run through a succession of typhoons in the Southwest Pacific that ran kind of straight west towards far southern China, northern Vietnam. And I'm not saying they ignited a wave train, because they weren't recurving typhoons, but one thing that's been notable this year, and we saw it for the first couple of weeks of October, which was that we kind of call it a black, depending on what your preference is, we call it like a kind of a blocking ridge north of the Caspian Sea, kind of Western Russia. Some people will say it's the Ural mountain ridge. And what we've seen is a fairly persistent ridge, which lies kind of east of Scandinavia and north of the Caspian. And that was noted all the way back to kind of late September. And what that's kind of done is it's done two things. It looks like it's set off of a unique, Asian cool troughing in kind of Central and East Asia with a really expansive snow cover. And you've kind of kicked off a few waves out of that ridge. Or the blocking ridge is kind of downstream, led to some waves, which may have found some coupling with something was happening in the tropical West Pacific. But again, herein lies kind of the murkiness of this time of year, right? We don't really have a great sense, and the models have almost no sense in terms of the handoff and energy streams between the tropics and the mid and high latitudes. So when you combine Epsilon in the Atlantic with two typhoons in the West Pac, and a persistent blocking high in Western Russia, in a place that has notoriously disturbed at times the stratospheric polar vortex. And I'm not at all suggesting this is a stratospheric polar vortex event, which has transpired this past week. However, nevertheless, is some really interesting kind of mid and high latitude competition with the tropics. And I think that those two energy streams, coupled with pretty warm water in the North Pacific, we got the cold to kind of form, in Western Canada in a kind of a La Nina favorable spot. But the La Nina is operating at like a really low frequency fingerprint. So, again, there's that, like, it looks like a La Nina verification with cold north and west and warm southeast ridge fighting that off. But, this is one of those really, really tough subseasonal stretches. And with as active a tropics as we had, and obviously the Atlantic has been a huge player, but the Pacific has been by no means quiet. So, I think we've seen an awful lot of struggles modeling wise because of that. But it was really a fascinating verification. Dave, can I share my screen for just a moment?
Yeah, sure.
Great. So I'm going to do that. I wanted to talk about one other thing. This is not related to, here we go. I don't know why it's not doing it. Yeah, I'm not able to do it right now, Dave. I'm not sure why. I think I have a firewall to show my. Let's see if this works. No, I can't. No, my work computer is not allowing me to share this for the moment, Dave.
Oh, okay. No problem.
Sorry. Maybe we can do this next week. I can figure out how to get this going. What I really wanted to share, I can actually screenshot this and send it to an email. And Dave, if you want to circulate it amongst the team there, what I really wanted to share was, this has been such a great time to be a forecaster, kind of at any forecast window. And what we've seen the last few days is perhaps the largest bust of a day ahead forecast for wind generation in the state of Texas, probably ever. So when the Arctic front came through Texas on Monday, and temperatures went from the 70s and 80s to the teens and 20s, and then freezing rain kicked off. Freezing rain, light snow, and ice pellets kicked off across West Texas. It did so over pretty dense wind generation areas, and wind turbines don't enjoy cold temperatures, and they certainly don't enjoy frozen precipitation. You can imagine, a mechanical device of that size with all the bearings and parts, ice is not a real friend to getting blades to spin freely. So just to give you a sense, a strong wind forecast day in Texas, and this was similar to Monday and Tuesday. They're expecting something in the order of, let's call it, Monday was expecting 18 or 19 gigawatts of wind. It's close to an all-time record for the state of Texas. And wind generation was less than half that. And then Monday's forecast for Tuesday was forecasting something around 10 or 12 gigawatts of wind. And they ended up getting around 2 to 2.5 gigawatts of wind. So about an 80% reduction in wind power forecast. So if you think you missed the subseasonal space and you beat yourself up over it, you can just get destroyed in a 24-hour ahead wind generation forecast and really beat yourself up for it. But Dave, I'll do a screen capture of that graph, and I want to send it to you so you can circulate it just to see the miss, and how really the risk was there. And I identified the risk correctly in that there's a significant downside risk to wind generation, but to get how significant becomes the issue. So similar to how when we make a temperature forecast, you can talk about the risk that lies within. But as with I think frequently with weather events, whether they're day ahead forecasts or 3-week ahead forecasts, one error we have as humans, and part of it is the models have this error, is we vastly underestimate the tails of the distribution. Meaning, nobody had that kind of setup in a week 3 forecast, right? With minus 20 or 25 anomalies in the Dakotas and plus 15 anomalies in the Southeast. Weather will frequently surprise us at different time scales. And so this has really been a great week, in terms of kind of fascinating weather. And then you throw a borderline Cat 2 going into Louisiana, late this afternoon, and we've got that complication. So there's just a lot on my mind right now in terms of kind of like what's moving, what kind of moving parts we're seeing out there. That verification there, right? You might get the right answer, and a lot of us did. We were close, but it's almost like you didn't show your work, and we got to get marked down for that, because the extremity of this pattern is really something that we're underestimating right now.
Yeah, it's almost too bad we didn't have the pattern forecast for this one, because it would have been interesting to see, would folks have, forecast something more like this, and like you said, just backed into the right number, or would we have caught on to, would some folks have caught on to something, different than what the EC was showing?
Right.
Dave, but there's one other thought I had about this, and there's just my opinion, but or my thought, but I feel like there's a rule when I look at this forecast. The other thing that jumps out to me is, I feel like there's a little bit of a rule of thumb that, like, you need cold air to build up, and first you have to build cold air mass, and then it has to come down. And I think looking at this, and I haven't looked at this in great detail, but from the maps we've looked at, this is an example of actually not how dramatically things can change, right? Because it's not like, even at this point, you brought up the gradient, and how, like, anytime you see a gradient like that, your alarm bell should go off and say, uh-oh, like, hey, listen, if I'm forecasting HDDs across the eastern 2/3 of the country, wow, this could be a very low confidence forecast, because, like you said, if it shifts a little east, shifts a little west, it could have dramatic impacts on the actual number, right? Important to note. But this was a situation where that wasn't even in the models, right? Like, at least the dynamic guidance. I'm not saying that no one, through other techniques could have seen that. But, when you look at the EC here, you look at the CFS, there's no pocket of cold air on this map, period. It's not like you can say, oh man, but boy, if that cold air that's over, when Western Canada drops a little bit further south and east, this forecast will be really cold. This was a situation where the Gulf of Alaska forecast, right? We looked at this earlier, was a bust, right? I don't know how to say it, right? 180. And within that time span, not only did we see a strong Gulf of Alaska ridge, but enough time for that Gulf of Alaska ridge to develop a downstream, really significant cold air mass that also had the time to drop into the northern third or whatever, northern half of the country and produce the kind of cold that Dave already mentioned, some record cold for this time of year. So all those things happen 16 to 20 days out without any of those. What, again, this is my sort of subjective, take, just based on rules of thumb that I've kind of considered in the past. Well, without any of those, early signals. Hey, there's at least a cold air mass over Western Canada. Hey, watch out because there's an Alaska ridge. Hey, all these things happened, and they really threw off the forecast. And in some respects, as Dave mentioned, in some cases, maybe we're lucky that the pattern evolved the way it did. Otherwise, some of our HDD forecasts could have been awful by a lot more.
Hey, Dave.
Yeah.
You can look at go back to the 500 millibar, 500 anoms, and let's roll that back. You rolled it back for me already a little bit, but let's roll it back to around the 10th or 11th of the month. Let's go like 3 or 4 days farther back from that window.
Right, there's 11th. There's the 6th.
Perfect, right? So this is great. So this is exact. This is kind of. So let's do this, Dave. So let's walk through this. The one thing we always will sometimes ask ourselves, or we should be asking ourselves, is kind of like, if it goes wrong, what goes wrong and why?
Right.
And so, I'm not saying that we got this forecast right. We got some good HDD verifications, but what I wanted to point out was when you have blocking like you're seeing over north and east of Scandinavia, when you see that kind of ridging, and then you've got really active tropics, right? So what you said a few minutes ago, Dave, was you like to see cold air build, and then you like to see the dynamics, of ridging in certain locations occur, and then you can deliver that cold somewhere. That obviously is a really important conduit or story in, say, midwinter, December, January, and February. But one of the reasons I love this time of year is kind of the quirkiness of what can happen. And with that blocking ridge and kind of knowing that it can spit off some really of like, I'd say hiccupy, like high vol, low forecast skill downstream impacts across Asia, East Asia. And knowing you've got some pretty active tropics running around underneath, I'm just saying it becomes tip off. And I know we do this in a hand wavy way, right? This is our challenge in this space, is that everyone wants a number, and sometimes you just can't forecast the number. And even if you do and get it right, you got the pattern completely wrong. We get a little hand wavy with these arguments by saying, I like the fact that the models are showing ridging across most of the lower 48, but we have tremendous cold over Hudson Bay in this pattern right now, the 6th through the 10th of October. We know we've got 2 tropical systems in the Westpac and probably another recurve. I don't remember if we'd seen quite epsilon and what was going to happen with epsilon at this point, but we did within a few days. Knowing that we were going to start seeing some funny tropical interactions with the mid-latitudes, at least it tips us off to like things can start to go awry. And I know it's hand wavy, but you can start to use statements like, I'm not sure where the risks lie. I just think that we're getting into a window where risks are starting to increase dramatically. You probably used some of those kind of, word choices in the past, Dave.
Oh, and worse. No,
Yeah.
but no. I agree. In fact, and Lynn, you may, I think Lynn's on the line. She may want to jump in here too in a second, because when I guess another way I think about this, Dave, and again, this is more experiential. I don't have hard numbers, but I agree with what you said. Like I think the Alaska Ridge is, my guess is, right, based on my experience, there are certain situations where it is relatively predictable, but I think there's other situations where it is less predictable, right? And the hard, right, the $1 million question is always how to understand those, right? Model diagnostics, situations where the forecast is very predictable, situations where it's not, and in particular, patterns like the Alaska Ridge, because at least for us, selfishly for the United States, that's a hugely important teleconnection, right? Alaska Ridge, arguably more than anything else, dictates whether we can have really severe cold or warmth, 5 to 10 days out, right? And I think there are still situations where the Alaska Ridge, like this situation, is not is very difficult to predict.
It's very non-classical. Absolutely.
What's that?
It's really non-classical.
Yeah, yes. yeah, exactly. And maybe it points to, I think, studying some of the things that Dave pointed out about, the Caspian Ridge, or, that ridge north of the Caspian Sea, and maybe some of these other patterns, and trying to distinguish, can you at least be in a situation where you could say, hey, maybe there's a heightened risk for a blow up, just like what we saw today. And I think, and I this might be a little bit of a tangent, but I still think back to the winter of 2013 and 14. And again, one of the cold winters of the last 30 years. And, we had that relatively persistent, continuous Alaska Ridge. And, in my opinion, it's still one of these things where it's like, why? Like there's, I think, still a question, it's still a research question to a degree, and this might be debatable, as to why was it so sticky in that period? Why, and then we have this situation where you get this, appears to be a synoptic event. Why? I think there's a lot there with the Alaska Ridge and understanding why it can pop up like that. And obviously because it's so important, because it does have such a big impact on our weather. I don't know, Lynn, I think you're on the line here. Is there, I know you've looked at this a little bit. Is there anything you want to add?
Yeah, sure, certainly. And this actually came into my mind, I don't know, probably about 10 minutes ago when we were talking. I think the thing that we learned the most from model diagnostics was that the models have an inability to match the extremes that we see in weather dramatically. Like the extremes on both ends, the models failed to simulate or go out as far as they should have always. So it's whenever we do have an extreme event, if we notice that the models forecast definitely something less than that. And I think this was sort of a perfect case for that.
Yeah.
Hey, Dave, you showed that the 15 or 16 to 20-day forecast had a trough over Alaska instead of a ridge. I'm curious, at what lead time did the ridge actually start to appear in these model forecasts?
Yeah, that's a good point. So let's go. So, on our little Dynacast site, we can move this forward, and we could actually move it forward at smaller increments. So let's just do October 6th, and we'll just kind of move it forward. We'll see how this looks, where we saw that pattern. So here's, sorry, I was going kind of fast. October 9th, so not there. October 10th, October 11th, might be a little delay. October 12th, again, everyone can do this at home too. 13th, okay, 14th, so we're starting to see some of those changes here. 15, 16, oh yeah, 17, 18, 19, 20, and I'll stop here in a second, 21, and now we're into it, right? It's the verification period was 21st to the 25th, so we're in it. 22nd, 23rd. All right, I'm going to go back now. Let's go back now. So obviously it's here. We're in it. But let's see if we can trace back. All right, let me go back in time. 20th. There's the 20th. I'll go a little slower. 19th. A little bit. Obviously there's more heights here across the Eastern Pacific in general, right? There's a wall of above normal heights, which generally, allows for some of that cold.
Hey, Dave?
Yeah.
Can I just make a comment about this map projection? I don't know if it's sort of screwing with anybody else's head, but looking at the size of China in comparison to the United States and the abnormally large size of North Africa, I don't know if the atmosphere in this map is distorted just as much as the land features are. So I keep trying to correct for that. And we might want to just keep in mind that the features we're seeing over North America are probably smaller in comparison to what we should be seeing over Asia, just because it's drawn as such a tiny place on this map.
Yeah, that's a good point. Some of these.
I'm assuming it's a polar stereographic, and so the further you get from the pole, the more distorted and probably larger.
Right, but China shouldn't. India should I don't understand why they're so tiny.
Yeah, yeah, I don't know, but I guess that's good to keep in mind. Just, yeah, there are some distortions.
So some of those features just might be larger than what we're seeing on the,
Okay.
in the eastern.
And you can look, I won't do it now just because I don't want to confuse folks even more, but you can look at global here too, and that's another way you could do it. Maybe, but that might be better for some folks. So, but let's just go back real quick here. I know we're spending a lot of time on attribution today, but I think this is a pretty good one. I think Dr. Decker's question was a good one because I think it does speak to predictability to some degree here. And it seems like the transition, yeah, maybe, arguably, it's the devil's in the details a little in terms of what you define as the change. But certainly here, this was not a Eastern Pacific, clear blocking or high anomalous ridge. So this is the 13th. So what's that, 8 days, Dr. Decker, before, the start of that event. So, somewhere in that 8-day range, plus or minus a day or two, depending on exactly what you want to define as that, East Pac ridging, it seems like we started to transition. So certainly not, not 15 or 16 days out, right? Which is where we were forecasting. Does that help, Dr. Decker?
Right. Yeah.
Okay. That's a really good point. That's a point for another conversation, I guess. Just for the sake of time, but it begs the question, and we can't quite answer this because we don't have all the model data, but if we had more time and the model data in front of us, it certainly would be interesting to see exactly at what lead time. We know it wasn't 16 to 20 days out, but at what lead window exactly did the models really resolve well the fact that, there was going to be a big ridge in the Eastern Pacific, and yes, there was going to be record cold and snow across the northern plains. Was that 8 days out, 10 days out, 12 days out? That's a really good question. Okay, I'm going to switch over to the forecast just so we can spend a few minutes on the forecast. But again, I think that was worthwhile. Sometimes it's easier to talk about the past than it is to talk about the future, isn't it? All right, but let's look at the future. So this is the forecast we all made from the 27th. Again, layout's just a little bit different. We kind of talked about it. I just tried to clean things up a little bit. All right, so Dave, why don't you why don't we put you on the spot again here, Dave? Because I know you did submit a forecast here. Why don't you talk about your forecast, if you don't mind, talk about your forecast rationale and thoughts on the current forecast.
Sure. So one of the tough parts about making this forecast is walking out of a verification like we just did, right? This goes into the closer's mentality of being a good forecaster is shaking off the last one, although you're probably influenced by it to some extent. I actually think that we are going to a weather pattern, or we may be cycling through another weather pattern that is not too dissimilar to what we just exited a few days ago. We're exiting now, actually, of kind of cold north and west and warmth south and east. I didn't feel like being a hero this week, so the non-hero forecast is to go something near the it's like a detrended Euro weeklies based upon its errors of going from week 4 to week 2. We do kind of an internal bias correction here, but heavily weighted towards the 10-year normal, which I think is around 95 or 96. No, it's 10. It's the rolling average. I think it's the rolling one, the one further down, Dave. Up there. Yeah, 98, 10-year moving average. Nevertheless, something in the low 90s. And then we see an MJO progression, which we're not really quite sure where the MJO is going to be in 2 weeks, but we've seen this progression of an MJO, which was a relatively strong event coming across Indonesia and the West Pac, but has held some coherency through the Western Pacific. And looks like we'll have 2 tranches of that. We're depicting 2 tranches, one that's kind of centered over South America and the Caribbean, hence one of the fertile grounds for Hurricane Zeta, and potentially another one in the next 10 to 20 days. And the next tranche of MJO signature, which would kind of be over the Indian Ocean or kind of Central West Indian Ocean. So I come with a 91. Doesn't really feel like I'm going on a limb there. I don't see anyone really that's kind of really sticking their nose out. But I did try to play this a little differently this time. I actually had a fairly wide what I thought was a reasonably wide distribution for the forecast verification ending Monday. And this one, I bumped my spread up to 27. Anytime you're going to be, 90 degrees in South Florida and minus 20 in the upper Midwest, feels like an opportunity to kind of open up your spread a little and at least acknowledge some of that uncertainty. We still got the Ural Ridge, the kind of Caspian, whatever, Westpac, whatever your flavor of geography you want to go with. That ridge is still present. At least one, if not two Westpac typhoons in the next, probably two Westpac typhoons, which look like they move into China. I don't know what kind of downstream amplification you get from that, but the models made a relatively large switch from Monday into yesterday, and that switch was Monday. They were forecasting out in the 11 to 15 day kind of perpetually warm look. And then there were some hints on Monday night and Tuesday morning, the 0Z runs, I call it the 0Z Tuesday runs, which you see walking in the Tuesday morning. And they were indicating that there would be another batch of cold forming in Northwest, kind of West Central, kind of Rockies of Canada. It should be noted too, Dave, there's a fairly, I don't know how much to attribute to a La Nina, but if you look at La Nina analogs to winter in general, and I'm not suggesting we're winter, I am suggesting we are in a La Nina pattern, or at least a La Nina base state. La Nina base states have cold air north and west and warm south and east, right? So the corridor from, say, Texas to New England is warm, and then you have cold that kind of increases as you go into the western Midwest plains, northern plains, and kind of western Canada. That's a classically La Nina look for winter. We're seeing some of that show up. I don't know on the time scale if it's proper to attribute part of this to a La Nina forcing. But you also get extremely, extremely warm water in the North Pacific, which may be helping to kind of mask cold in kind of central Canada, a place which has had obviously tremendous expanse in snow cover in the last 2 weeks. So that's kind of it. It's a great opportunity to kind of feel like you could make a hero trade out of this, but I don't know if anyone really kind of stuck their neck out there. Yeah, there's that snow cover. It's really pretty impressive. That should flatline a little in the next 10 days because we're going to get some melt in the Conus and maybe a little bit in Western Russia, but in general, it should stay above trend line. The other thing that's being batted around, Dave, is kind of the persistence of some of the kind of the subarctic ridging, north and east of Scandinavia. That's an area where there's been little to almost no ice expanse in the last, for the beginning of this cold season. Tremendous amount of warm open water, or relatively warm open water now, north of north central and northwest Russia, I guess that would be. There's potentially some feedback which is occurring there that we're not really seeing, or the models really aren't seeing, and the feedback there is going to be interesting to watch the next, I don't know, month or two probably. So that's the long and short of it.
Hey, Dave, what do you think about, I did see, oh, by the way, did you create a map?
I did not. I overlooked that.
Okay.
I promise one next week.
No problem.
Okay.
The EC, kind of warm, right? I mean, relative to 76. What do you make of that? Is that, you said something about a bias correction?
Yeah, so we've been making some fairly hard bias corrections. The ECs have been notably warm weeks 3, 4, 5, and 6, pretty much since the end of summer. And they've had to make progressively colder changes, but their colder changes tend to be the largest from week 3 to week 2. So, there's a component of the EC which we feel like we can bias correct. How close that's getting us to the real answer, we're not sure. We just know that there's been a very consistent requirement to increase EC HDD numbers, or at least back in September was to decrease CDD numbers. So I don't know if this is something that's wrong with the EC's feedback in seeing those outer weeks, but they're having to make a lot of cold changes. Weeks 4 to 3, and then particularly 3 to 2. Missing. So that kind of gets back to like where you were suggesting before with Dr. Decker, which is, the Alaskan ridge doesn't show up 15 days before before you saw the kind of the quote unquote weather. it's more like in that 8, 9, 10-day space, which speaks a lot to like the EC having to make large cold changes going from week 3 to week 2. It's almost like you have to get it almost to like borderline synoptic scale space, kind of like end of week 1, beginning of week 2, right? Roughly day 8 to 10 before we see it. And that's common, right? We've seen that, or, we've seen that our whole career, Dave, right? Which is oftentimes it's like, you like to think you can see a feature 15 days out and then walk it home. But we typically will walk in like on a Monday and be like, well, this is what the maps look like when I left on Friday.
Right.
But that, there's a lot of hiccup, there's a lot of noisy stuff which happens and gets cleared up kind of in that, day 7 to, 12-day space. So,
I mean, that's some pretty good insight for us, for the forecasters here too, just to watch out with the EC. Maybe there's a warm bias here, and that's something to look for in our or consider when you're making your forecast. Okay. Any other questions for Dave? No. Okay. Who else wants to give it a go here? Sean or Dr. Decker, would you like to share your forecast?
Mine I can do real quick, so I guess I'll mention it. So I always just take the CPC forecast, even though it's for 14 days instead of the 5 days that we're forecasting for, and try to turn it into a number. I did note there is that implied gradient in their forecast where if that cold air expands a little bit more. I don't know if you can bring up so they do have that cold over the sort of northern Great Lakes, northern plains area. If that were to expand south a little bit more into more populated areas, I could have a big impact on the HDDs. So I think I bumped up my spread a little bit to account for that. But overall, it's clearly a warm forecast, although the probabilities aren't that high compared to some other day, week 3, 4 outlooks that we've seen in the last year. So I didn't go too bonkers, but I did go a little bit below the climatology in terms of HDDs based on more warmth than cold.
Any questions for Dr. Decker? Oh, did you? Okay, yeah. I was thinking, this is related, I guess, to what both you guys have talked about. I'm just looking at this, when I look at the EC here, again, it's worth what you paid for it, but it feels to me like something doesn't add up in terms of if there's this amount of block, like I shouldn't call it blocking necessarily, but whenever I see a wall of ridging across the Eastern Pacific, I always feel like, wow, there's potential for a lot of cold air, at least across Canada, right? You put a wall of ridging, you block the Pacific flow, this time of year, anytime in the fall and winter, and, you're likely to build cold to the lee side of the Rockies.
Hey, Dave, can I jump in on that?
Yeah.
Go back to that. Yeah, stay on that map for a moment. The one thing that stands out to me, too, is it's not just the ridging in Western Canada, and this is actually going to be a contrary argument to cold. It's going to actually favor more what Professor Decker has just suggested, which is really a warm-leaning forecast. The large feature in the Pacific that stands out to me is the trough in kind of the Western Bering Sea. Underneath that is a pretty large ridge, right? So there'd be a fairly vigorous Asian jet, which will tend to be more poleward directed across the Western Pacific. Extensions of the Pacific jet, which are more poleward directed, tend to favor mostly warm CONUS in winter. You want a jet which is centered not north of Japan, but more over and south of Japan to favor cold, right? There's some body of research, which we were going through in the last week. There's a few papers that have been written about this, which has been, the Pacific jet is the larger modulator on kind of, blocking, anti-blocking. And to me, if this is the Euro, right? Yeah, this is the Euro. So this to me says that jet, which you can kind of picture a line going from northern Japan towards the Aleutians, would be, the extension would be east and north, typically not warm scenarios. There's also a fairly vigorous Atlantic jet, notably, pretty deep Icelandic low and a pretty large Azores high underneath. So these are not great ingredients. I see where the Euro's coming up with the forecast. And I agree with Professor Decker. Like if we can't get the handoffs right with tropics and kind of some high latitude stuff, where I think the bay state is warm to maybe exceptionally warm. Right, places that are, you can see this in the next 7 days in the U.S. Like places that have been in the single digits and teens in the Rockies and High Plains are going to be in the 70s and 80s by next Tuesday and Wednesday.
Yeah, and I think those are all good points, right? So there's a lot of counterpoints there across the Pacific.
It's not a forecast. It's just all we're doing is identifying the things that we worry about.
The only thing, and we'll see 3 weeks from now, the only thing that still bothers me a little bit, put aside, I agree about the uncertainty in the United States. It just still, it would surprise me with this amount of ridging, if that develops, that there isn't a stronger cold pool somewhere in the central and eastern Canada. And this kind of goes back to, I think a little bit what you said, David, just, if that ridge is really there, put aside how much penetrates into the United States, which ultimately is the most important question for the, for the HDD number. But is it really just going to be normal kind of conditions in central and eastern Canada with that much blocking? I would be, again, this is my experience, I'd be suspicious of that. But regardless of that, right, I think, Dave, yeah, you bring up, and Dr. Decker, good points. Ultimately, how much is going to get down, into the United States, and of course that's going to be dictated not only by the amount of Alaska ridging, but of course, right, the amount of undercutting, right? Maybe there's more undercutting, as Dave kind of alluded to. Maybe there's a break here, and of course, positive NAO, right? That was, obviously that can be a big, that can be a really important modulator in La Niñas, right? Because in La Niñas, you typically expect you're going to have some degree of anomalous cold across Western, Central, North America. The more debate is exactly how much is going to get into the United States. But of course, if you have a negative NAO, it gives it more ability to come south. And this certainly does not look like a negative NAO, just the opposite. Okay, well, we have 2 more minutes. Anyone want to do a quick blurb on their forecast before we go? Sean, did you have a chance to make a forecast here?
I did make a forecast. Yeah, I actually based it off of pretty much everything you just said. I feel a little shooken up from the last verification though. I was close, but like everybody stated, for the very wrong reasons. But I went primarily with a neutral PNA and AO and NAO signals to cause a zonal flow. And I had that blocking propagating eastward during our forecast period so that it would keep the flow more zonal and not allow any of the pooling of the cold air that could develop in eastern Canada to come down into the States. That is what I anticipate happening. So I went with basically the climatology for it. I averaged the 30-year with the 10-year and went with a safe bet on that one.
Okay. And did you create a map?
I did. I just had everything. I just had it all gray though.
That's a normal map. All right, good. That's not
that's
not a bug.
Normal.
Right. Okay. Hey, listen, you never know. You never know.
Well, I thought I'm anticipating it to be almost completely zonal flow. So I figured average temperatures across the country.
Yeah. Okay. Okay. And speaking of the map, Dr. Decker mentioned this on the chat a minute ago. Like, hey, maybe terciles. Keep it simple. In terms of the different categories above, normal, and below. Basically a third each. The top third would be above, middle third would be normal, the bottom third of the distribution would be the below. That seems like that could be the most straightforward way. So we can think about that going forward. Okay. Well, that might be a good place to leave it. I know Dave's got a busy day with all the models and stuff like that. So yeah, thank you everyone, but in particular, Dave D'Arcangelo, thank you for joining us today. And I think it was a really good discussion in terms of the previous forecast and, kind of taking a sneak peek into what's lying ahead here over the next 15, 20 days.
Yep. You're welcome, Dave. Thanks for the invite. I really enjoyed it.
All right, cool. All right, great. Thanks, guys. Have a good rest of the week.
Thanks, you too.
Bye-bye.
Yes.